Hi everyone, my name is Fabian Schreim. I'm one of the co-founders at Civil Maps. I'm also the VP of Research and Development here at the company. Thank you for joining us for our continuing webinar series on getting started with sensor data for autonomous cars. Today I'm filling in for Scott and David, who are traveling. And the topic of today's session is around sensor fusion, and in particular, we're going to be talking about sensor fusion for vehicle cognition. This is an overview of what we're going to be discussing today. We're going to start with a brief introduction, going over the definition of sensor fusion and what it means to different people in the industry. We're then going to talk about the map as a sensor. So how can we leverage 3D semantic maps as sensors, part of our sensor suite, on the autonomous vehicle? We're going to be discussing some prerequisites for sensor fusion, both on the hardware side and on the software side of things as well. Today, as part of this webinar, we're also giving out a small challenge. We will be sharing with you some data and some code to play around with cognition as we define it here at Civil Maps, and in particular, sensor fusion. Before concluding, we're going to be showing you a few more examples of cognition through sensor fusion and taking some questions from the audience. So I have the list of questions here open in front of me. If you feel at any point that you want to ask a question, don't hesitate and type it up, and I would be happy to answer it when the time's right. Great, so let's get started. This is a recap of what we've been showing in this webinar series for the past couple of sessions. It's a representation of the pipeline, the data pipeline as we see it at Civil Maps. So Civil Maps is a company which is dedicated to providing cognition for cars. We are the layer that sits between the sensors, giving us their sensor data, and the decision-making engine on the other side. So we're getting that sensor data, extracting context from it, and giving it over to the decision-making side of things. The way we do this is, first of all, by having a hardware abstraction layer. This is necessary for us because we don't have just one hardware configuration. We work with different machine vision sensors, different inertial sensors. We also work with different OEMs, and even our own platforms vary depending on the iteration. The hardware abstraction layer allows us to normalize this data coming from different sensors in a way that we can use in the rest of our stack. After the hardware abstraction layer, we get depth data that we utilize in two different ways. So we take this point cloud or the disparity maps, and what we do is we localize the vehicle very precisely on our map, but we also audit our map. We verify that it's still complete and correct. Because we're localized and we have an existing notion of what the environment looks like, we can then take the map and present an augmented reality view of the world through the vehicle sensor. So in this example that we're showing here, we have overlaid the map on top of the camera feed.